Junior penetration tester. This is the learning path that we're working on. And yesterday we've gone through authentication bypass. I said we might not be able to go through it in an entire video, but we did. Now I'm going to say the same thing about the IDOR, about today's room on this learning path. And there is a lot of stuff to be working on when it comes to introduction to web hacking here. More forward down the road, we're gonna see Burp Suite with quite a few rooms here. That's gonna be interesting, and I'm really excited about it. And then network security. Like I said, I believe it was in the first video. I'm not really interested in Nmap, but this is a very basic tool. I mostly never use Nmap in my penetration tests. Then we're going to go through vulnerability research, Metasploit, something that I'm really not passionate about, and privilege escalation. Again, something that I'm not particularly excited about. Now, we are at IDOR, so let's see what this is all about. Again, I'm going to try to keep this video in the ballpark of 20 minutes. So let's start the attack box and see if there's any other machine here. There might not be a machine. Only an attack box. We might not even need the attack box, but anyways, in this room you're going to learn what an IDOR vulnerability is. Make sure that it's recording. What they look like, how to find them, and a practical task exploiting a real case scenario. IDOR, most recently known as BOLA. So IDOR BOLA. It's broken object level authorization, which it has been named according to the recent OWASP guidelines. So IDOR stands for Insecure Direct Object Reference and is a type of access control vulnerability. This type of vulnerability can occur when a web server receives user-supplied input to retrieve objects, files, data. So this is actually the standard definition of IDOR, but to be honest, you can find IDORs in any places when it comes to examining a request. So if you would be using Burp or some sort of a proxy to your web requests, you should be actually looking for IDORs in all parts of your request. What does IDOR stand for? Insecure direct. So this is BS from TryHackMe, which is what I don't like. Insecure direct object reference. I don't like it because this is sort of like CTF-ish stuff. Why do you ask me what's an IDOR when it actually says over here? Is this some sort of a room for kids? If it is, what can I say? An IDOR example, though I have to give credit where it's due, so there have been very good situations and scenarios so far in this learning path. So overall, my experience so far is generally positive. Imagine you've just signed up for an online service and you want to change your profile information. The link you click on goes to this, and you can see your information, user ID. Alright. Curiosity gets the better of you, and you try changing the user ID value to 1000 instead. And to your surprise, you can now see another user's information. This is the very most basic example of an IDOR, which more often than not in recent scenarios it doesn't actually happen like that. It's kind of harder to find IDORs, but it's still a widely encountered vulnerability, and to that matter, it's one of my favorites. When I do penetration tests, the main thing that I'm looking for is authorization issues, IDORs, authentication bypass, and logic flaws. And to your surprise, you can now see, and very little I'm looking for input validation. I don't go too much beyond the basics because that's not the point when you're actually doing a penetration test, the point is to have something very well secured, not 100% bulletproof, which can never actually take place because everything, all the technologies that are powering a website or an application or an asset are in a constant change, and you have to be aware of that, because if this thing is quite secure today, it might not be tomorrow, because one of the technologies might be vulnerable to a certain 0 day. You've now discovered an IDOR vulnerability. Ideally, there should be a check on the website to confirm that the user's information belongs to the user's log requesting it. And this actually happens via authentication headers. Using what you've learned above, click on the View Site button and try to receive a flag by discovering and exploiting an IDOR vulnerability. So, how do I actually change things here? Click through the emails below and try to identify an URL that looks like it could potentially be vulnerable to an IDOR attack and click on it. 1, 2, 3, 5. Or they're not found. 1, 2, 3, 3. Let's actually go back. 1, 2, 3, 4. So it's probably this one. 1, 2, 3, 4. 1, 2, 3, 3. 1. Let's actually 1, 2, 3. Let's see if 1, 2, 1, 2, 3, 9. 1, 2, 3, 5. Try changing the number below viewing order 1000. Alright. What is the flag from the IDOR? This one probably. Finding IDORs in encoded IDs. When passing data from page to page, either by post data, query strings, or cookies, yum. Developers will often first take the raw data and encode it. Encoding ensures that the receiving web server will be able to understand the contents. Encoding changes binary data into ASCII string, commonly using the A to Z capital, 09 and equal character for padding. The most common encoding technique on the web is base 64. And this is the website we've been looking yesterday into, which is the very most basic base 64 website, the very most user unfriendly, but it does the job. And then resubmit the web request to see if there is a change in the response. So what is the string that we actually need to decode? You can use websites like this to decode the string. Alright, see the image below as a graphical example. What is a common type? So we have the base 64 encoded. EAJ is often the character sequence that is encountered in JWT tokens. Decoded means ID 30, we're tempering it by actually modifying into ID 10, we encode it back and we submit it, and boom, you have an IDOR. What is a common type of encoding used for websites? Base 64. Finding IDORs in hashed IDs. Hashed IDs are a little bit more complicated to deal with than encoded ones, but they may follow a predictable pattern, such as being the hash versions of the integer value. For example, the ID number 123 would become this thing if MD5 hashing were in use. It's worthwhile putting any discovered hashes through a web service such as CrackStation, which has a database of billion of hash to value results, to see if we can find any matches. So what is a common type of algorithm used for hashing IDs? It's MD5. There's also SHA-1, SHA 256, SHA 512. The latest ones are the better ones. Finding IDORs in unpredictable IDs. If the ID cannot be detected using the above methods, so one way is, instead of using ID equals to 1 or ID equals to 1000, Now, this is in terms of defending a web application or securing a web application. You would be using a GUID or a UID, but better said a GUID in the form of this one, like this. And this type of unpredictable pattern is much harder to get to the bottom of it when you're testing for IDORs. So yeah, what is the minimum number of accounts you need to create to check for IDORs? Between, I would say, 2. Alright, but we didn't read this. So IDOR detection is to create 2 accounts and swap the ID numbers. Now this is the very most basic way to look for IDs. If you can view the other users as content using their ID number while still being logged in with your account, for example, or not logged in at all, if you're not logged in at all, the situation is even more critical. You found a valid IDOR vulnerability. Where are IDORs located? Everywhere. The vulnerable endpoint you're targeting may not always be something you see in the address bar. It could be content your browser loads in via an AJAX request, or something that you find referenced in a JavaScript file. Sometimes endpoints could have an unreferenced parameter that may have been of some use during development and got pushed to production. For example, you may notice user details displaying your information, but throughout an attack known as parameter mining, you discover a parameter, which is actually basically finding out other parameters. You discover a parameter called user ID that you can use to display other users' information. For example, if your user ID is 122, you go to user details user ID. This is found via parameter mining or via fuzzing. For example, if you're using FUF, you can simply say here slash user slash details slash, not slash, but question mark fuzz equals, or not necessarily fuzz, but so if you're actually looking for parameters, you could simply do fuzz here, and if you're looking for IDORs, you could simply do user ID fuzz, and make sure to filter for different responses. But anyways, for example, user detail, there's nothing to be answered for. A practical IDOR example: start the machine. First, you'll need to log in. To do this, click on the customer section and create an account. Is it available right now? So it's going to be available in 50 seconds. What is it that we need to do? To do this, click on the customer section. So we need to create a user account. The your account section gives you the ability to change your information, such as the username. So we'll go into our account. You'll notice the username and email fields are pre-filled in with your information. We'll start by investigating how this information gets pre-filled. If you open your browser developer tools, select the network tab, then refresh the page, you'll see a call to an endpoint. So this is going to be interesting. The page returns in JSON format your user ID, username, email address. We can see the path to the user information. So customer ID, this is something that we might be able to find an IDOR at. You can try testing this ID parameter for an IDOR vulnerability by changing the ID to another user's. Try selecting users with ID 1 and 3 and then answer the questions below. So pretty straightforward. Right now we're going to customers, sign up, username Christian, email address christy@christian.com, password admin1, again admin1, sign up. We are onto the dashboard. We're looking into your account. We are loading the web developer tools. We refresh the page. Customer ID equals 15, and we can replay this Can we actually replay this somewhere with a different user ID? So if we look at all of them, the customer ID, we should be able to, so this is actually a GET request, and we can simply, why don't we just copy this, because I'm not going to fire up my burp suite right now for that. We do have a cookie, a session cookie. Let's try actually doing that. So customer ID 15, this is my username and my email. Then if we do customer ID 1, we see 1, and customer ID 2, we see 2. So we're not actually following what they're saying here, but we're trying to get the answer for an IDOR by changing the ID to another. Try selecting the user. So what is the username for user ID 1? Wasn't it Adam? Adam 84. What is the email address for user ID 3? This one. All right, so this was a good representation of IDOR. I would say it was surface level stuff, but really good introduction to IDORs. Like I said, you can notice here that we have the request headers. We have accept, connection, cookie, host, refer, X requested with. We have the payload, which is ID, which this is what we can temper, but in the request headers, everything should be tested for. Like I said, when you're tempering requests, you can look for IDORs in all the fields that are in your request, and that's most easily achieved with a proxy such as Burp Suite, or even with Firefox tools, with Firefox developer tools. I'm not really sure if Chrome DevTools has the option to replay and modify requests, but regardless, this was an interesting room.